In the previous video, we looked at the graph of y equals x squared, and it turns out to be like this, something like this. I can't draw neatly. So here, this is a graph of y equals x squared. If you try to draw a graph of y equals x, it would be a straight line, straight diagonal line through the origin. Okay. Now the next question is, what is y equals x to the power 3? What does this graph look like? Y equals x to the power of 3. Okay. So as always, if you're trying to investigate this graph here, try to create a table for yourself here like this: x, y, and then 1, 2, 3, 4, 5, 4, 5, and so on, and create a table of values here. So you put 0 into this thing here. So well, if this is saying get whatever it is times by itself 3 times. So if you put 0 into here, it would be 0 times 0 times 0. That would be 0. If you put 1 into here, when x is 1, well, it would be 1 times 1 times 1. That would be 1. If you put 2 into here, it would be 2 times 2 times 2. So this is 4. It's like 4 times 2. So that would be 8. Now put 3 into here, it would be 3 times 3 times 3. So this is like saying 9 times 3, which is 27. Okay, and the thing is, if you try and plot this on our normal standard graph, it will look like this: 0 here, 1 will be here, 2 times 2 times 2 times 2 times 2. That will be 8. So it will jump all the way up here. And then when it's 3, it's 27. The thing is, it jumps off the scale here. This is, well, 15 is the highest. 27 would be will be somewhere up here. It's off the scale, so you can't tell much from this graph. So you have to change the scale. You see from here to here is 1. From here to here it's in segments of 1 here. Our scale is not big enough. We need to squash it down. So this one here, hang on. So now I know it looks strange here. Just bear with me for the time being. So from what I'm saying here is from here to here is 50. Okay, and then from here to here is another 50. From here to here is another 50. It's pretty much the same as this graph here, but because I need to squash everything down here to squeeze to be able to plot the graph so you can see this, because at the moment I can only go up to 3. 3 is already off the scale, so I need to squash everything down. So here let's squash everything down. So this is y, this is x. I know it looks a bit ugly, but just bear with me. So let's try and do this again. So this is our table here. We are trying to investigate y equals x to the power of 3. So put the 0 into here. That would be 0. Put the 1 into here. That would be 1. Put the 2 into here. That would be 8. Put the 3 into there. It means 3 times 3 times 3. That would be 27. Put the 4 into there. It means 4 times 4 times 4. So this here will be 16. So it's like me saying 16 times 4. Okay. So this would be 24. Sorry, 24. So this here would be 6. Okay. So this here would be 64. And 5. Put 5 into here. It's like me saying 5 times 5 times 5. This here will be 25. 25 times 5 is 125. So this is 125. You see, by having a scale like this, we can actually plot this. Hang on, let's plot this. So when x equals 1, y will be 1. When x equals when x equals 0, y will be 0. When x equals 1, y will be 1. So on this scale here, from here to here is 50. From here to here is 50. But when 1 is going to be really close to this on this scale here, because if you think about it, from here to here is 50, so 1 must be the microscopic height there. Well, when it's 2, it's still very small, but it's still higher. I'm going to guess 8 to be around here. When it's 3, it's 20, 27. So, well, 25 is here. So 27 is here. Okay, well, roughly there. Now 4, 60, 4 would be 64. Let me think. Yeah, 4 would be 64. So on this scale here, from here to here is 50. So 75 is here. So 64. We are trying to plot y equals when x equals 4. Y will be 64. So we are trying to plot 64. So I'm going to guess 64 to be around here. Okay. And when it's 5, it would be 125. So 125 would be 100 is here. 125 will be dead in the middle. So it will be here. Okay. 6, I think it will be off the scale. So well, 6 times 6 times 6 was just like me saying 36 times 6. So this would be 36, carry a 3, 18, 20, 21. Okay, so it'd be 200 and yeah, it's actually off the scale. It's somewhere up here. Okay. Well, anyway, let's look at the negative side now. When you put negative 1 into here, it basically means negative 1 times negative 1 times negative 1. Well, let's merge these two together. 1 times 1 is 1, and then negative and a negative. That would be a positive. So when you merge these two together, it is 1. And then don't forget, let's just take this down here. So it would be negative. The overall answer is negative 1, because when you're at this stage here, 1 times 1 is 1, but there's only one negative, so the overall answer is minus 1. So this one here is minus 1. Okay. Now the same with the minus 2. Well, it basically means minus 2 times minus 2 times minus 2. Let's merge these two together. That would be 2 times 2 is 4, 2 negatives, so that would be a positive. So when you merge these two together, it becomes a 4. Take the minus 2 down. So now merge these two together. That would be a negative 8. Okay. So this thing here would be negative 8. Now let's look at negative 3. Negative 3 times negative 3 times negative 3. Let's merge these two together. This would be a positive 9. Okay, times negative 3. Merge these two together. It would be negative 27. Okay, so it's pretty much, it's in a way, it's very much similar to the right hand side, but the thing is, it remains a negative because you're multiplying by itself 3 times. Well, anyway, I'm just going to copy this over here and stick a minus in front, because it's pretty much the same. If you look at the positive side here, so you've got 4 times 4 times 4. Over here, you've got minus 4 times minus 4 times minus 4. It's pretty much the same, but when you come to deal with the negatives here, you've got a negative and a negative. The two will cancel out, and then you're left with one negative. So the overall answer would be the same, but then you have a negative. So I'm just going to copy this over here. This will be what minus 1, 2, 5. Now, if you try and plot this here, hang on. So now when x is minus 1, y will be minus 1. So I'm going to guess right here. And then when x is 2, y will be negative 8. So I'm going to guess around here. It's pretty much the same as this thing here, but it's in the opposite direction. It's in the negative side. So hang on. Negative 27. I'm going to guess around here. Okay, it's a bit messy, but bear with me. So here, minus 4, it would be 64. So minus 4, it would be minus 64. I'm going to guess around here. So 5, when it's negative 5, this one here would be 125. So it's going to be here. So when you try and plot this, it will actually look something like this. Bear with me. It's hard to draw curves on here. Hang on. Let me just do this. Bear with me. So here, if you try and plot this, it will look something like this. It's really hard. It's really hard to draw. Hang on. Well, anyway, it's gonna. Hang on. Let me have one more try. So it goes through the origin, and then it's sort of like it's the same but in the negative direction. Well, anyway, that's my best attempt. So let's recap. Y equals x. It will look like this. Y equals x squared. It will look like this. It will look like this. Okay. Y equals x to the power 3. It will look like this. Hang on. So it will look something like this. Something like that. And it climbs up really fast. So it's quite steep. Okay. And also, if you try and investigate y equals x to the power 3, let's say plus 7, well, everything gets shifted up by 7. So y equals x to the power 3 plus 7, it will look, everything gets shifted up by 7. Okay, so it's pretty much the same shape, but it's well, it gets shifted up by 7. So yeah, just like your diagonal line here gets shifted up by 7. Well, and then if you have y equals x squared plus 7, x squared plus 7, x squared looks like that, x squared plus 7 looks like that. It gets shifted up. Well, x to the power 3, x to the power 3 looks like this, looks something like that. Okay, well, if you try and investigate x to the power 3 plus another number, let's say 11, it gets shifted up 11. And if you minus 11, it gets dragged down 11. Okay, every point gets dragged down. So y equals x to the power 3 minus 11 would probably look something like this. Okay, well, anyway, but the most important point is y equals x to the power 3 will look something like this. Well, not like that. Not like that. It's hard to draw. So something like that. Okay.